Okay, so we spent around 35 minutes. Okay, 35 minutes, 35 minutes on around. Okay. Okay, so recall back. So particle, you want to find the smallest particle, grouping done again. Too many particles has been found. So now they group into hadron and lepton. What is hadron? It's a group of particles which experience strong nuclear force made of quarks. Okay. So what is leptons? Group of particles does not experience strong nuclear force. They themselves fundamental particle. Okay. So electron and neutrinos are leptons. Hadrons can have 3 quarks, can have 2 quarks, 3 quarks, proton and neutron. Okay. Okay, so yeah, so now the development is after Rutherford, then Rutherford find nucleus, then proton was also by Rutherford, and now currently like quarks. The development of the particle accelerator leads to more particles, quarks. Yeah. So you see, this is a very interesting diagram. Atom to nucleus, nucleus is proton, proton to quarks, quarks to what? The research is continuous. Up to now is confirmed quark. Okay. So another thing is we still haven't. I can't say still. We still don't have technology to find the smallest one for time being quark. Okay. So this is called particle zoo. You see, don't get worried about too many particles here. The one important you need to know is the quarks and the leptons. The third group you don't need to know, okay, but not in your syllabus. The quarks you need to know the quarks you need to what? You know the up quark, down quark, and strange only. The charm, these three no need. Okay. So up quark. So, and for leptons, there are 6. The one you need to know is electron and electron neutrino. These two you need to know. The muon tau, good to know, but they won't ask an exam. Okay.
So the neutrino that comes out from beta and alpha is called electron neutrino.
Yeah, electron neutrino.
So do we call it neutrino or electron neutrino?
Good to see the word electron neutrino because that's the only one they ask in your A levels. You put neutrino also the exam you only know it's electron. Okay, so there are a lot of particles here, but the one you need to know is this fact. That's it. Okay, this fact. Okay, so electron got 6, but the one focus is electron and what do you call? This tells the antimatter. Muon got antimuon, electron got positron. Okay, electron with beta. This symbol is the neutrino symbol. Neutrino, antineutrino. Antineutrino we normally put a bar on top. Antiparticle normally you put a bar on top. Okay, electron we never put bar, we just put positive. You see, muon like on top is muon bar. We put a line on top. It's called antimatter. Antimatter we normally put bar. Okay, so you know up quark. We come to that later. So bar means you put bar is antimatter. Okay, the exact symbol was repeated but with bar. Antimatter. Okay, so electron just focus to electron. 6 leptons, fundamental particles. Everyone is a fundamental particle here. Electron, muon, tau, and 3 neutrinos. Electron, neutrinos, muon, neutrinos, tau, neutrinos. Focus is electron and electron neutrinos only. Does not react with strong nuclear force. They never react with strong nuclear force. React with other 3 forces. Gravitational, the other 3 forces they react to, but not strong nuclear force. Charge is either -1 or 0 for leptons normally. Yeah, -1. 0 for neutrinos. Neutrinos is a particle which is no charge, very little mass, 1,000 times much more smaller than the mass of electron. It's very lighter than electron. Yeah, so that neutrinos are no charge, negligible mass. We thought electron is the little mass, but this one is even smaller than electron. Okay, there are so many neutrinos which are produced early as Big Bang, emitted beta decay. Beta decay, you get neutrino. The most almost 0 charge. Charge is 0 and mass is almost 0. Travel at almost speed of light. Recent studies they say it exceeds speed of light. Still researching. Okay. Interact with little other particle due to its very small mass. Interact very little. Never really interact with anything. Very little mass, no charge. That's why it's difficult to find neutrino. Okay. Okay. Now we go for quarks. Quarks, 3 quarks. Fundamentally, they are fundamental particle. They have no internal structures. They themselves as a single unit for time being. 6 flavors. Interact only with strong nuclear force. They have fractional charge. Yes, quarks has fractional charge. They don't have integer. The fractional charge. 1/3 or 2/3. Okay, so this is the table. The quarks, this is the charge possessed by the charge, but there is a big mistake here. Sorry, this should be plus. This should be negative. This is positive 203. The sign is opposite. Okay, it's not negative, it's positive. This 2 is negative. The charge you have to remember. Up quark, what is the charge? An exam they will ask. Positive 230. Down quark, negative 130. Strange quark, negative 130. Okay, charge you have to remember. So symbol for up quark, U, down quark, small d, strange quark is S. So next is anti-quark. Up quark, we put a bar. Anti-up quark bar. So the charge is positive 2/3 for up quark. Here will be negative 2/3. Anti-particle is charge is opposite. So down positive 1/3. Anti-strange positive 1/3. Okay. antimatter. So these are the things you have to remember. Okay. So hadron, any particle that made of quarks and antiquarks, subdivided into baryon mesons. I told you baryon mesons, the term you don't need to remember, is fine. Baryon, 3 quarks, proton, neutron is a 3 quarks. Meson is group of particles which made of 1 quark, 1 antiquark. 1 quark, 1 antiquark, combining together. So far, they never found anything other than this combination. But again, I think last time we don't have that technology. But now technology is improving. Recently, I think that day I saw one article came out and in the CNN, they found a particle with 5 quarks together. Okay. For A levels, 3 quark and 2 quark only. So far they combined. So example, pion count, this all you don't need to remember. It's good to know. Even the term meson baryon, you don't need to know. The only thing you need to know is hadron made of 3 quarks or 1 quark, 1 antiquark. The baryon also can be 3 antiquarks. Can be 3 quarks, can be 3 antiquarks. Okay. Baryon, no mixture. 1 quark, 2 antiquark, never happen. Either 3 quark or 3 antiquark for baryon. For meson, 1 quark, 1 antiquark. Okay, no 2 quark for meson. 1 quark, 1 antiquark. Okay, our focus is about our old members now. Of course, proton, neutron. Proton, both made of combination of 3 quarks. Proton found to be made of up, down. Made of up, down quark. You combine the charge, positive 2/3, negative 1/3, you get positive 1e. Proton, positive 1e because of up, down combined charge. So now A levels, another one level, proton made of quarks, made of up, down quark. Up quark is positive 2/3, down quark is negative 1/3 e. Last time you said positive 1, but now A levels positive 1e. You must say E, elementary charge. Real exam, if they ask what is the charge of electron, you put negative 1 wrong. You must put negative 1e. Okay, so yeah, this is what has been predicted. The up, down was is together inside the proton with the strong nuclear force. They experience strong nuclear force between them. The neutron is up, down, down. Neutron is found to be up, down, down. So total charge is 0. Up is positive 2/3, down is negative 1/3, negative 1/3, so becomes 0. This is what has been visualized. Neutron made of up, down, down quarks inside. Okay, so fundamental forces, gravitational force, electromagnetic force, weak nuclear force, strong nuclear force. The last two is there something new addition into your force. Weak nuclear force between quarks is weak nuclear force. The beta emission due to the weak nuclear force. The strong nuclear force is between the nucleons. Alpha decay. So proton, neutron between them is a strong nuclear force. Inside the quarks all have weak nuclear forces. Beta emission happens because of the weak nuclear force. Okay, so yeah. The beta emission happens due to what? Due to weak nuclear force between the quarks inside the proton and neutron. Yeah. So now let's see beta decay. We know proton change to neutron, beta plus neutrino is produced. But in reality, what is happening inside? Proton is what? Up, up, down. But neutron is down, down, up. What has been changed? One up quark has been converted to down quark. That's what happens inside. Up quark has been converted to down quark. Quarks, it seems, can change. Okay? By receiving energy from invisible energy, or they can change up quark, change to down quark. The proton seems to be changed to neutron, and one electron, positron, and neutrino is produced. Yeah? You can call it as beta positive. I think better. Beta positive. You said positron also should not be a wrong statement. Positron, beta positive should be accepted. But I believe go for beta positive better. Okay. So there is one here they ask what happened to proton change to neutron? So up quark change to down quark. Too many protons, I already told you. Too many protons will break up to form a neutron. Positron, neutrino is emitted. Beta decay, neutron change to proton. What happened? One down quark change to quark. Neutron change to proton. Beta negative, antineutrino. These two are very famous formulas frequently asked in exam. Proton change to neutron, neutron change to proton. When that happened, what quark changed to what quark? Okay. Yeah, so down quark changed to up quark. Okay. Okay, next. So too many neutrons breaks up to form a proton and electron and antineutrino. This slide is very in depth. You don't need to know. It just tells the down up quark up quark become down quark, releases some sort of energy, later tend to become electron and neutrino. This is mass energy conversion happens. Mass converted to some sort of energy, that energy changed to suddenly become mass again, form matter and antimatter. This energy is called boson. Another type of energy particle, which is not in your syllabus. Okay, so this transformation happens due to weak nuclear force between the quarks. Weak nuclear force. During proton-neutron decay, weak nuclear force between the quarks allows quarks to exchange themselves. Okay. This takes place exchanging boson. Boson is not in your syllabus. It's another fundamental particle, but not in your syllabus. Boson. Yeah. Okay. Mesons. One quark, one anti-quark. So this all are this extra information actually. You don't need no mesons. You must know quark, anti-quark can form a particle under hadron. Kaun and pion. This is extra information. Okay. Okay, so for time being, this is what imagine proton, neutron, proton. The force between them is a strong nuclear force between proton and neutron, but inside is a weak nuclear force. Solar arrangement. Okay, yeah. So that's all about this topic. Okay. The last part is about particle. Okay. So can we recap? So what do you learn about particle? Particle break into 3 groups. Second group got only 2 groups. What is that? Hadron and lepton. Hadron What is hadron? Strong nuclear force made of quarks. And lepton, particle experience, not experience, weak, strong nuclear force. They are fundamental particles. Okay, what is the lepton member? Electron, neutrino, electron and neutrino. And there is another form. Baryon, hadron, proton and neutron, 3 quarks. What are the formation can have? 3 quarks, 3 antiquarks, 1 quark, 1 antiquark. Possible arrangement. 3 quark, 3 antiquark, label it as baryon. Okay, 1 quark, 1 antiquark is meson. Okay, quark is a fundamental article for hadron. What causes beta decay? Strong nuclear force or weak nuclear force? The weak nuclear force causes the beta decay. The up quark change to down quark, so beta decay happens. Okay, beta decay happens. Okay. Okay, another one. Gamma ray, when comes out, all rays will have the same energy. When alpha comes out, every alpha particle will have the same energy. Okay, when released. But beta, when beta comes out from the nucleus, the beta will have a range of energy. They will have a range of energy. Okay, the beta decay. Okay, why? Again, the blame is the energy was shared with the neutrino. Sometimes beta take more energy, neutrino take less energy, and so on. So in exam they'll ask which radiation has a range of energy? Beta. Beta is found to have a range of energy emitted from the nucleus. Okay. One electron might have a less kinetic energy, the other one might have more kinetic energy. Okay, they have a range of energy. Okay. Okay, so yeah. So some questions, maybe another 10 minutes. Okay. Okay, so we go overall now. So what you learned in the nuclear topic? Something new? I think in the last part, the particle. Earlier, anything new? No, I think Rutherford experiment you learned before, and nuclear reaction also you learned before. Okay. 38%, sir. Which statement describes beta negative decay, beta minus decay in terms of simple quark models? Beta negative, what changed to what? Neutron changed to proton, or proton changed to neutron? Neutron changed to proton. So neutron, what is the composition of neutron? Down, down, up, become up, up, down. So down become up. Yeah. A down quark changes to up quark, emits an electron and electron antineutrino. Yeah, antineutrino. Okay. So A is the answer. If beta plus, what's the answer? If beta plus decay, then what's the answer? Beta plus, proton change to neutron, totally opposite, right? The up quark change to down quark, emit positron and neutrino. Positron and neutrino. One matter, one antimatter. Okay, 39. Yeah, beta positive. So B, proton change to neutron, electron and electron neutrino. D, B. Proton change to neutron, positron, electron neutrino. So this is the main two formulas lah, very frequently. Okay. Okay. Right. Boy, proton hadrons, electron is lepton, neutrino also lepton. It's a boy. Okay, next. One example of hadron, proton or neutron. Pion count, if you proton neutron famous. Lepton, electron or neutrino, electron neutrino. And proton is up, up, down, and neutron is down, down, up. So easy question, nucleus, actually, fact to remember. You remember the facts about particle, I think should be okay. Okay. See? So neutron change to proton and beta negative or beta positive? Beta negative and anti-neutrino. Okay. Till the change in quark composition of the particle, down become up, down quark become up quark. Okay, so about five quarks. Okay, next. Strong nuclear force or weak nuclear force? Weak nuclear force. Okay, weak nuclear force responsible for the beta decay. Inside the quarks bonding, it's weak. So 3 marks. So you can tell Manila. Alpha is positively charged. Oh, the alpha and beta, both are positively charged. So you can't tell positive charge now. Larger in mass. Okay, yeah. Alpha as a magnitude of charge is greater than the beta.
Beta positive charge varies like beta negative.
Oh, charge not varies, the energy range. Alpha has a fixed energy and beta will have a range of energy when emitted. Mass, alpha is more massive than beta. And what else? Alpha particle is made of quarks. Alpha is actually what? Helium nucleus. Right? Helium nucleus. Nucleus made of what? Nucleus, 2 proton, 2 neutron. They made of what? Quarks. So alpha made of quarks, and beta is lepton. Is a fundamental particle. Oh, that's another one. Alpha is not a fundamental particle. Beta is a fundamental particle by itself. These are the differences you have to tell. Yeah. Okay, yeah, that's all. Okay, so we're done with the AS. Next week, another 1 week to go. So I believe you do your past years. Next week, Wednesday, can we go for one full set of objective questions?
Yes.
One set of paper.
Yes.
The main topic. Okay, when next Wednesday, yeah. Okay, so tomorrow onwards, I think tomorrow we do some. I think fine with nuclear. I think tomorrow onwards we can start our revision. Oh no, can't. A2. Yeah. Okay. We go for revision next week. Monday. Today is what? Today is Tuesday. Yeah. Okay. So tomorrow we're going to start with another topic, but A2 topic, circular motion, which quite related to your AS sometimes comes in as an extra knowledge. Then next week, Monday onwards, we do a revision. Okay, 1 week revision. Okay. Yeah.
Is the positron the opposite of the beta particle?
Positron is antimatter.
Can I say that the ionizing power of positron is the same as beta particle?
Yeah. Okay.
Just oppositely charged.
Oppositely charged. Yeah. Still varies. Which one? Yeah, varies. Beta always a range. Range, yeah.
Is the range similar? Yes, it's very.
Oh, could be varies also because depend to the nucleus. They have a fixed range.